went remote, and let's get going. Actually, did I just get something from her? So this is the note. Well, you already agreed to this. For some of the working groups, this is, and it's in your registration pack and such. For some working groups, this is sort of pro forma. On the other hand, we know in this working group that patents are important. So is a lot of other intellectual property. So please, if you don't feel like you have read the note well, please go read it again. Your contributions are important, but they're very relevant here. And there are some other things that other people put up for at the beginning of working group meetings, the let's be nice with each other and such. That hasn't been an issue here, but definitely it's Tuesday. Go read the rest of the welcome packet. So we've got a fairly packed agenda, especially because the last bullet item, the remainder, is going to probably run on. So I'm not doing any agenda bashing. We're just going to get into it. If there happens to be time at the end, we can do open mic for everything. I suspect there won't be. Some of the last two have a lot of slides. So with that, let's start with post-quantum cryptography for engineers. Oops. And it does want it. I'm confirming, and you can just tell me next.
Hi, everyone. I'm Aditra, and I'll be presenting PQC for engineers today. It's been a really interesting draft. We have received a lot of reviews and a lot of comments. Let's move forward. Yeah, a brief overview of the draft. To somebody who is new, it explains why engineers need to be aware and understand post-quantum cryptography, and it emphasizes the potential impact of CRQCs and the need to transition to post-quantum algorithms to ensure long-term security. It was adopted after the IETF meeting 117, and since then we have had many iterations for that. Yeah. Some changes since the IETF 118 meeting. In Prague, we have added in a section, basically a subsection where we provided the signature sizes for LMS schemes as a comparison to basically stateless scheme, which is Sphinx. We added in a small ciphertext on the caution of basically ciphertext commitment in Chem versus Diffie-Hellman. We added in a point of hybrid schemes being in CCA2 robust. That means if you want your hybrid schemes to be in CCA2, you should have at least one in CCA2 scheme in there. And we have finally changed the names to MLChem, MLDSA, SLHDSA, and EventDSA, which will be merged quite soon. Yeah, the LMS key and signature sizes we have defined according to 4 parameter sets on the hash function, the length of the digest, the tree height, and as well as the Winternitz coefficient. Somebody familiar with RFC 8554, and for the draft we have a table of the digest size of 32 bytes. And please go ahead and look at the table, and please provide some review if needed. Next tenth, we'll probably sync name change for the PQC algorithms, and we'll merge the latest version. And we'll provide some minor updates soon via PR on GitHub. And yeah, that would be all. There hasn't been too much for significant changes, and we don't foresee many significant changes, only minor updates in the future. Thank you.
So you went very fast, which is great. So instead, there might be some questions of could this be in the draft and such. Please don't bring them to the mic. That's great on the list. Does anyone have any questions on the updates that they've done, like the updates since the last 2 versions that he covered? Okay. This has been doing well on the list. A lot of people actually have concerns about, should we be going this deep? Should we not be going, should we be going less deep? Those are all great discussions on the mailing list. It's a longer document than where it started.
Yeah, it's around 42, 43 pages right now.
Right.
Yeah.
However, what many people have discovered is people have lots of questions, and we don't know if we're answering too many of them. So let's keep the keep the discussion on the mailing list going. We're not in a rush to finish this, but at some point we will, call it baked and send it to IETF last call. Thanks.
Perfect. Thank you.
And next up is terminology.
Oh, sound all right?
We can hear you, Flo.
Great.
Yep.
Awesome. Well, hi everyone. I'm Flo, and yeah, I'm just going to talk, hopefully, equally briefly about the terminology draft. Next slide, please. So this is a very similar context slide to the one I've shown at the last few meetings. This is a informational draft to standardize a glossary for post-quantum traditional hybrids, so constructions which use both post-quantum and traditional algorithms. I'll note something here, which is while it's an informational draft, it's still information that is important that it stays stable, because a lot of the protocol drafts are relying on the definitions staying the same because they're using them. So the aims are there, you can read them. I guess the big change since the last meeting is that we had a working group last call, which finished last week or the week before. And the conclusion from that was that it was not ready for publication yet. But I just want to say thank you to everyone who contributed to that, because as always, a really good thing about working group last call is it will pull people out of the woodwork to tell you what they'd like to get changed, and that's all really valuable feedback. So what I was going to talk about today, I wasn't going to go into the kind of changes that have been made in the latest version of the draft, because you can go and look at the diff. I'm happy to talk through them if people would like to. But what I was going to focus on was the kind of what I think are the major considerations following working group last call. I'm also very happy to hear others' views about what their takeaways are of those major considerations. So next slide, please. So I think there are kind of 3 things that came out of working group last call, plus a bunch of small things which will just be updates. So the first is there are kind of various things that we could achieve from this draft. I think that we can probably all agree that language around post-quantum, language around hybrids is going to develop probably for the next decade. We're never going to be finished here. But there's a question about how far we want to wait for the language being used in academia and in industry to evolve, and also the language and also the concept to evolve, versus trying to get this published so that we've got some stable terminology for those drafts and those papers to use. I think there's a balance here, and it's just a choice to be made by this group. I'm interested in others' views. I'm interested in any experience that people have of doing work like this. But that's something that we need to bear in mind. It might be the case that this just sits aside and we wait with it. Mike, do you want to come in now, or?
Yeah. Test?
Yeah.
Yep.
Yep.
Yeah. So, I mean, if this is the goal, then I wonder if we should remove some of the more academic-y stuff that's only been coined in the last year and sort of strip it down to the stuff that's a bit older and more stable.
I think that's a really good point, and I've been wondering about that. In particular, I'm not sure exactly what you're thinking of, but to my mind, the most academic language is the stuff around signature spectrums. And given that that's now in a different draft, I don't think there'd be much lost to the IETF as a whole if that was removed. So I think that sounds very reasonable to me.
Yes, exactly.
So that was the first kind of big question, timings. And I think this kind of comes to a head a bit once NIST published their drafts, so probably next IETF meeting, hopefully. But yeah, discussions ongoing there. So the second big thing, which has come out a little bit on the list, but also in discussions separately, is the trouble with the word composite. I think there's lots of drafts that use the word composite. It seems to be a kind of helpful concept, but actually pinning down exactly what composite means versus what hybrid means, where you define things as composite, where you define things as non-composite, has turned out to be a lot more complicated than it appeared at first. There's discussions ongoing about this. those discussions are mostly not on list, just for ease. If people have thoughts and are interested in being included, please do let me know. This has been a challenge since starting the draft, so anyone with any really bright ideas is incredibly welcome. And I can go into that in more detail if people are interested. And then I guess the third point is sort of related to Mike's comment, but also to some of the feedback on the working group last call. What words do we actually want to find here? So some of that might be, how academic do we want to go? Some of it is this language actually going to be used, or are we just making it up for the sake of this draft? Some of it might be, I don't like this idea, so we shouldn't give people the language to discuss it. Personally, I think I disagree with that. I think if people want to use phrases, it's good for that to be clear. I guess what I'm asking for on that final bullet point is that if you're working on a protocols draft, if you have strong feelings about concepts that you'd like to have definitions for, things you would or you wouldn't like included, then please do let me know. There was some really helpful feedback on this at the last meeting about terms around certificates and certificate chains. But yeah, any strong opinions, do let me know. So next slide, please. Yeah. Next steps. So I haven't updated the draft yet, but I will be making updates based on the working group last call comments and any other comments on the list before hopefully the April interim meeting, to give people time to feedback on that. And then I'm sure there'll be lots of discussions to try and add precision to what composite means, where we use it. I think the next slide just says get in touch. Yeah, please do get involved. This really needs to be a joint effort, particularly from individuals who are working on other drafts around post-quantum or hybrids. Stephen, yes.
Stephen.
Hi, Stephen. So one of the comments I had was that I think some of these new kind of forms of being hybrid create new kind of anti-patterns, and I suggest it would be good to have some names for those. I don't know, and we don't need to figure out what those should be now, but is that something you think is worthwhile or something you think is not worthwhile?
As I said before, I think naming things which people want to be able to grasp is useful. And if that includes anti-patterns, it wasn't then I'm happy to do that. It wasn't something I'd thought of before, but and like I said, I haven't really thought through the details, but your comment on work group last call flagged it, so it's something that I'm certainly not opposed to, and I'll see what we can do in the updates.
Great, thanks. I mean, I think it could be useful to save people time elsewhere when they're talking about reusing a classic private value multiple times for different things. So some terms there would be good, I think.
So Stephen, can you? I'm not going to say send the whole list, to the mailing, all of the ones you've thought, but can you prime the mailing list with at least one like a named anti-pattern that you think of?
I'm not sure you'd like my name.
No, it's fine.
But
doesn't matter if I like it or not.
I think I did that in the comment already.
Okay. Just I would like to see people go, oh well, if we're going to talk about that, we should also do this and such, and get that going.
It's basically, if you have hybrids and you could reuse the classic part for a signature standalone and as part of the composite.
Yeah. Okay. Great. Thanks.
Yeah.
Great. Thank you, Flo.
Thank you.
And then coming back to chair slides, selection, and spectrums. Yep. Okay. So this is the quick update on this. Oh, Britta, I didn't know that you didn't have slides because this is going to be fast. Do you want to do this? Do you want to say where you're at?
Quickly give an overview. I know we have about a minute and a half here.
Okay, thank you.
So I'll give a quick, first of all, overview and reminder of what this is. The hybrid signature spectrums draft is really aimed at providing a trade-off overview for those who are looking to implement hybrid signatures about what the different ways of doing this are and what those security properties are and so forth. So a reference point, because there actually are quite a few trade-offs in the different ways that people have gone about this. So what we've done so far is we did an adoption call that solicited a bunch of feedback, which was fantastic. Thank you for that and everyone who contributed. We are incorporating it. It was all very straightforward, and we expect to have a new version available in the next few days. And then we'll do another adoption call, and then hopefully go from there.
Okay, very good. Do you want to explain the weapon behind your head since it's related to the IETF?
No, that's a secret.
Great. So again, once the authors put in a new draft, there'll be another call for adoption and discussion and such like that. So that's how we will go. Okay, so Alexander? I do. Or I believe I do. I should.
Testing.
This is you. And you got 5 minutes.
I'm Alex. I present this on behalf of the other people who co-authored this thing. Next, please. This is a document that aims to create a taxonomy of use cases where post-quantum crypto is relevant, as well as a taxonomy of approaches we can apply. And the idea is to give you some sort of guidance to which tool to choose for which particular job. And a secondary objective is to start a discussion about this subject. Well, the discussion has already started quite a while ago, so maybe just, foster and keep going. Next slide, please. What has changed since the previous IETF? We got some feedback we incorporated into the document. As a result of that, it became smaller and easier to read, we hope. And we introduced a category of use case, so a categorization based on 3 different criteria. That is, the first one is how long does your thing have to be out there, short-lived or very long-lived? The second criterion is what kind of protocol type you have. Is it something that has some sort of negotiation functionality inside, or is it you configure it and then you set it and you forget it? And the third criteria is, do you have to be backwards compatible? So you take those 3 elements, and we also put together a flow chart, which hopefully will help you go through reasoning such as, do I need backwards compatibility? No. Do I need to have it out there in for a long life cycle? Yes. Use X. So it should be easy. We hope this flow chart might be useful, at least to start discussions within teams, or if you strongly disagree with something in that flow chart, then of course, go ahead and provide feedback. Next slide, please. The next steps, as we see them, is I would like to collect more feedback from everybody. Whatever challenges you encountered in your attempts to solve a problem, I'd like to hear those stories. Whatever questions you've encountered, I would like to know what they are, and perhaps in the next iteration of this document, we could formulate solutions that address those specific questions. And I want to point out that I would rather prefer to treat this as an anthropologist talking to people from different tribes, rather than an auditor scrutinizing your actions for the past year, at very high level of detail. So it should be a relaxed type of interaction. And you can use whatever mechanisms IETF offers for feedback collection. There's also a GitHub repository where all this stuff is available. And I'm here all week. Just find me, talk to me, and I'll be glad to listen to your stories. That's it.
So this is not yet a working group document. There will be a call eventually at some point if you actually want it to be in the working group and such like that. But it's okay to discuss it on the mailing list as a pre-working group document. And Chris, you're in the queue.
So the draft is the title is post-quantum migrations.
Mm-hmm.
But when I'm reading the document, it seems it focuses mainly on digital signatures. Is it the goal to focus on this, or expand it?
So post-quantum is a big thing.
Yeah.
Within that big thing, the scope is narrowed down to digital signatures in particular.
All right. Cool.
But if you have an exciting story which is about, let's say, something else, chems, I would like to hear it too.
Great, thank you.
Thank you.
Oh,
Could I run the slides?
You can run the slides. Except I think I just lost you. Oh, here. Hang on a sec. Grant, there you go.
I see them. I think you will also see them.
Yep.
Okay, so I'll just immediately jump into it.
Yep. And do remember you have 5 minutes because I know you have a lot.
Yes,
of
yes. I know. Half of them are memes. Don't worry. Okay, so hash-based signatures schemes is something you've probably heard of in the context of quantum, and together with a bunch of people, we got together and sort of sat down to help run these things. But let me acknowledge that I have co-authors and then move on. What is a stateful hash-based signature scheme? Basically, they're lists of one-time use signature keys. And if you just reuse one of them once, it's completely game over. You have arbitrary signature forgery. It's all very, very, very bad. So keeping track of which signatures you've already consumed is really super important. And that is what we call the state in stateful hash-based signature schemes. In this document, we sort of set out how do you deal with this. Dealing with state is very hard. It's very scary. I mean, there's a large, really big problem if you just mess up just once. And it's like this divine commandment, thou must not use the key more than once. But how do you do that? Well, probably avoiding stateful schemes in the first place if you can. But and if you really have to, then you probably should buy like special hardware, but you don't solve all of your problems just with those two things. How do you reliably deploy these things, and how do you run backups? And that is the sort of thing that we sort of try to give handholds for in this document. So we introduce a bunch of terminology and requirements. We document operational considerations. We have a sort of an inventory of potential solutions for state management and backups, both within and outside of the scope that NIST SP 800-28 allows. And we, for very specific scenarios, we show you how, and a lot of these things have come up before by other people, how you could run things slightly differently. And one of those things you could do slightly differently is, for example, instead of using state that you need to save and store and protect, you just rely on the clock. You divide time in epochs. You only allow one signature per each epoch. And then if you need to restore a backup, you just know, okay, it's now this time, so I know that these signatures are still good. But I mean, people are probably familiar with the reference material I'm going to share. Keeping things with time is actually very, very hard. There's not just one, but there's two different X case studies about this. And we continuously see that particular time is just very difficult. This is from a few days ago. Leap day is still very hard, and it's not just limited to fuel pumps in New Zealand. This is what a friend at a Dutch bank told me last week, that their HSM vendor told them that they would please not roll out any configuration changes on leap day.
And for those of us in America with daylight savings time, it gets worse.
I believe that we can fill entire working groups with the drinking associated to time issues. Anyway, this sort of, aside from the memes, we have like what you should, if you want to do something like this, you need to make sure that you have like clock synchronization, timekeeping, and like 16 other PCP14 keywords to make such an approach work. This is just one of the examples. We have different things like tying into version numbers for software, etc. Very brief introduction. By no means is this document finished. I think that this is very much a sort of wisdom of the crowds thing. So we would very much like to welcome ideas, discussion, etc. And yeah, with that, I'm out of slides.
So we do, if since this is again pre-adoption work that people have expressed interest in, if anyone wants to do a quick question or comment now, we still can do a little bit now, but there'll be more on the mailing list and such like that. And I'm not seeing anyone in the queue. So thank you, Tom, and there'll be more on the list for this.
Yeah, I'll send an email with a brief introduction of the document.
Great, thank you. Thank you for releasing it. I don't know how to force you off. So, Mike, are you giving the talk? Is Ori giving the talk? Are you both? Okay. And if Britta wants to jump in, she can as well.
Britta's also here.
Yes.
Ori's taking the long way around. Get up here. We've rehearsed this not at all. I don't know how this
I was
is
going to say,
go.
if you want to go for it. Okay.
All right. So this is an attempt to demystify some of the, I think Flo correctly pointed out that composite is overloaded as a term. We're trying to sort of demystify some of the very closely related concepts here. So let's go. So the talk outline here is we're going to go into words composite, unlinked, I forgot to change the slide. Unlinked multiple signatures, linked multiple signatures, and counter signatures in the way these constructs are showing up in different working groups and how these are slightly different. And then we're going to go into existing RFCs, LAMPS, OpenPGP, Jose Cose, then show that some of these things actually already exist and some of them don't. And so the question then is, do we actually need to define new things, or do the things that already exist cover all the needs? That's basically the point of this talk, is do we have enough multiple signature mechanisms, or do we really need new ones? I don't know when Ori's going to take over, but you have your own mic, so I guess you can go. Okay, definitions. Protocols part. Okay, mandatory XKCD. The point of this...
It's not mandatory. You can't punish the earlier ones for not having an XKCD.
I think we had a CFRG in Japan where every single talk had a Randall Monroe in it. All right. So we're trying not to define anything new in this slide deck. This is not a research talk. This is a what already exists talk. We had a great fun putting the slides together and being very diligent about not inventing new words. Okay, next. So first definition is hybrid, or we're calling multiple algorithm scheme. So this is the sort of generic top-level umbrella term. This is borrowed directly from Flo's draft, a cryptographic scheme that incorporates more than one component algorithm where the component algorithms have the same cryptographic purpose. So you have two signatures, or you have two chems, or you have two key transes. Same with same. There's some examples: a traditional, a post-quantum traditional, a post-quantum, post-quantum. These are all examples of hybrid or multiple algorithm scheme. Next. Okay, so within the family of hybrids or multiple algorithm schemes, we're going to talk about a few here, and we've tried to sort of picture them out to show at what level the binding is happening. So unlinked parallel signatures comes in two flavors, and you notice the picture is the same for both flavors. The OR modes or the AND modes, and the important property here is the verifier and what the verifier thinks and how the verifier has been configured. So whether it's an AND mode or an OR mode is actually structurally identical, but the verifier has been told to treat it as an OR or treat it as an AND. You have linked parallel signatures where there is some structure, there is some evidence, and this cross links with Britta Hale's spectrums draft, in that if you remove one, it will leave evidence at the protocol layer that it was removed. You then have composites, which is semantically a single key and a single signature. You can unpack it to discover there's multiple inside, but semantically it is a single object. And then finally, you have counter signatures, which are nested in some way. So the protocol is, you perform a signature and then you wrap it with a second signature. All right. So then moving along, unlinked parallel signatures, it's exactly what you expect. It's two completely unrelated signatures. Sig1 is done with one algorithm, Sig2 is done with another algorithm. There's no cross-linking whatsoever. This does not achieve any non-separability property as per draft Hale. There is protocol layer linked parallel signatures. So the document contains two detached signatures with some sort of linking information between them. And so the example here, sort of the simplest possible example of this is I'm going to sign the message M, and then I'm going to tack on the end also an ed25519 signature exists. And in the ed25519 signature, I'm going to tack on also an MLDSA signature exists. So this is, your most basic attempt at an AND mode. If you just drop one, it leaves some sort of artifact that it was dropped. So this aims to achieve weak non-separability. Next. Counter signatures or nested signatures. So here you're wrapping them in some sense. So the first one is performed bare on the message. The second one you sign over the original signature. So this is sort of some weird like half and mode in that you can strip it in one direction without leaving evidence, but you can't strip it in the other direction. So in general, this doesn't achieve any non-separability properties, but depending on your protocol, how you're using it, you might maybe be able to argue it does in one direction, maybe. Next. Okay, here's the weird one. Composites, which we spent, I don't know, Ori, how many hours did we spend on the phone making these slides?
A long time.
So this is maybe a bit invented language on this slide. We're calling this crypto layer linked parallel signature. So we're trying to make the claim here that the word composite is equivalent to crypto layer linked parallel signature. So the goal is to bundle two things to look like one thing to achieve protocol backwards compatibility. Look, one key, look, one signature. You can put it in your existing signature field. It's not two things, it's one thing. And the security property here is that the composite signature values are bound to the composite algorithm ID. So the verifier has been told to verify a MLDSA ed25519 signature. It knows that both components are supposed to be there, and in protocols that sign over the algorithm ID, it leaves the evidence that way against stripping attacks. So we're considering composites that aim to achieve weak non-separability. There's a lot of devil in the details about getting the implementation right to actually achieve that property, but I think anyone who's doing composites, the aim is to achieve that property. Otherwise, there's no point in doing it.
I think this is where we switch. You can find my chair. You want this? All right, so we're going to cover instantiations of these examples, and just can you go back one slide for 1 second? This is where Mike and I spent the most amount of time talking, and here you see this crypto layer piece, and the crypto layer piece versus the protocol layer piece is like, I think, the key topic that we spent the most amount of time discussing. So in the examples that you can advance now, in the examples and protocols, you're going to see places where a protocol layer piece might fit in, and protocols where they can't do anything unless you give them a crypto layer construction. Next slide. So the first is the unlinked parallel signatures, and these are references that we were able to find within LAMPS and OpenPGP. I'm not an expert on either of these, so hopefully they're correct. Next slide. I'm sort of an expert on these, although I've made this slide very small and it's hard for me to see. This is RFC 7515 JSON web signatures, which supports multiple signatures over the same message, and RFC 9052 CBOR object signatures, where you have a similar construction of multiple signatures over the same message. So this is the unlinked parallel signatures use case at the protocol layer, with algorithms that are registered for HOSI or algorithms that are registered for COSI. Next slide. So from a pro-con perspective, unlinked parallel signatures, mechanisms exist. We just mentioned a couple that are out there. There's a single algorithm that communicates the signature type. Keys can be restricted depending on, there actually, we spent a lot of time kind of paying attention to the differences in keys and signatures across these different protocols. So some of the comments on the keys are, if they seem weird to you, it's probably because it's my fault. Yeah. So the key thing here is like you can add these parallel signatures over time because you always have the same message that you're able to sign and then add another signature and sign, add another signature. And the order isn't known between them. You don't know which one came first, and you know that all the signatures are signing the same message. So the con there is like, you're going to have to manage multiple keys. I can just take the signatures off at any point. And the verifier has to make sense of like, I was expecting 4 signatures and there's only 3, or, other issues with the signature algorithms that they were expecting, because they're all signing the same message. So there can be complexity on the verifier side for handling these. Next slide. Uh-oh.
Russ Housley, is the comment you made about you can't tell when they were put on there important to the later discussion?
No.
I don't think so. There's one on counter signatures.
I won't delve into it, but there is an attribute called signing time
in CMS. Yeah. As I said,
if you just prefix Ori's sentence with "in general," then
okay. Yeah. Okay. I don't understand CMS, so as I said, anything that's wrong on the slides is my fault. Next slide. Right. So now we're going to talk about protocol layer linked parallel signatures. This is my favorite one because it's in CMS, and we couldn't find any examples of any of the other ones, and CMS is, you're going to see CMS is like everything. It's super cool.
So this is a mechanism that already exists. It allows you to cross-reference. So one signer info can say, by the way, there's 2 other signer infos. Here's a hash of the first one. Here's a hash of the second one. So turns out CMS does already have a protocol layer linked parallel signature where if you strip one, it leaves cryptographic evidence that there should have been one more and which algorithm should have been there. So bravo CMS, you've got it.
Next
When
slide.
you use that mic from the table, it might be better if you were a little closer. Some of us can't hear you.
Eat the mic.
Eat the mic more. Yeah, basically, congrats CMS. You've done this thing where you can have multiple signer infos. You can cross-link them. You can indicate that I'm a RSA signature and also an MLDSA signature exists. And if it's stripped, you know that there should have been an MLDSA. That's what this extension does. And it's cool. Congrats CMS. You did it.
Next slide. So basically what Mike just said, protocol layer, linked parallel signatures, a mechanism exists for CMS. You can use this mechanism with single algorithm key construction. So like you've got the building blocks there. And this would allow clients to continue using existing traditional certificates and add a PQ certificate. So like it is a building block that you could start to use to add signature schemes of varying strength or against different problems. So you can start to level up the combination. That challenges the multiple keys inserts approach still. And the hybrid security property has to be enforced at the protocol level layer rather than the crypto layer. So like the point where I was making at the beginning, like this is a protocol layer binding. A raw crypto layer binding, is at a different layer. So it's cool that CMS supports this, but like if we were to go back to that other slide and see all of those other nuns, it's possible each of those nuns could be filled in with a very, very different construction that was kind of offering the same properties. Next slide.
Sorry, I'll add one point to that. Is we've had debates a lot about, there's there's specification writers, there's cryptographic library implementers, and then there's protocol library implementers, and how the higher up you go, the more people there are doing that, more people, more room for mistakes, more implementations. If we can get it lower to the crypto library, there's more expertise.
Do you want a quick one?
Yeah, Thiru Nokia. What happens if an attacker removes one of the protocols if it's done at the protocol level?
So, it's CMS. Do you want to answer?
Right. So I don't want to spend a lot of time on this specific draft. We can talk about the draft after, but so you have a signer info. In fact, you have two signer infos and they're cross-linked. I think they hash each other. So the hash of each signer info is cross-included and the signing algorithm of the other is included. So if you strip one out, you'll have a signer info that says, oh, and by the way, there should be a second signer info on this algorithm. And the verifier will say, okay, well, where is it?
Right. So the verifier has to catch that, basically. Yep. Next slide. So counter signatures, they're pretty well supported in several different protocols. We left this red piece. I thought, I don't know, maybe they might be in OpenPGP. I don't know. We don't know. They definitely exist in these other places, and versions of counter signatures also exist at the protocol layer, like in message structures, especially in like HOSI and COSI, and kind of domain-specific applications of like signatures that have hashes that point to other signatures. So this is definitely a thing that exists. Next slide. So a similar set of pros, there are constructions exist, single algorithm keys, they work with them. You can start to do that layering, but you have this one direction stripping problem that Mike was mentioning. So like if your second layer was a PQ cert, and I just take that off, there's a problem there. I'm not going to comment on the weak non-separability piece. I mean, I don't know any of the security properties for what happens with this, but I know that it's like a thing over time. Like, so Russ's comment about time for the other one, I mean, there's definitely an order to these, and you can definitely take the latter ones off. Right. So this is kind of the main summary around linked crypto layer, linked parallel signatures, aka composites. So when we looked at all of these, we thought, this was like the strongest, and it was at the right layer, basically, because if you had this, every protocol that had a signature that had the interface of like keygen, sign, and verify could use this and wouldn't have to deal with these multiple keys. And if you have a good construction for this, you're going to be able to drop that in a place where you previously would have had just a traditional signature scheme. I don't know that I want to read all of these words.
Yeah, I will read the second to bottom one though. So this is an interesting point. Improve interoperability through normal IETF registry process, because we can actually name them. We can call them. We can say, here's two things that are allowed to be combined. And we can implicitly say, here's a bunch of things you're not allowed to combine because we're not registering them. So it gives IETF the ability to control combinations.
Yeah, and we could share them, right? So we could say, this combination is actually COSI is going to ask for a code point on it. HOSI is going to ask for a code point on it. CMS is going to ask for a code point. PGP is going to ask for a code point. And they're all actually they could all potentially all use the same underlying cryptographic library that would give that capability, and we could share security proofs and all of that other good stuff for doing this work at this layer. However, as I can see in the queue already, like there are lots of good reasons to maybe not do this. And so I think we're going to there's like maybe one more slide, hopefully.
Stephen, do you want to comment on this specifically? Or?
Okay. So the protocol linked parallel signatures, these are the ones that we know that we can see drafts for that are out there. And just a concrete example, like MLDSA with P256 ECDSA or MLDSA with ED25519, like that kind of construction. Again, these are protocol layer linked parallel signatures. So the thing I was just talking about, like, we don't have that, but we do have these. Next slide.
On this slide might be wrong.
Aaron Whistler?
No, it's
Aaron?
title's right, I think.
Hi. Yeah, so OpenPGP, I think the red text fits pretty well because this draft is like provisional and this is the hot topic of like tomorrow morning's discussion. That is exactly whether we want to go in this direction. So this is the author's proposal, but it's not yet full in the working group. Like we've had 100+ email thread about this. And yeah, there's going to be like a half-an-hour discussion tomorrow morning if you want to join.
To be fair, that's also true of the LAMPS draft.
Cozy and Hosey don't have a draft that's like that. So here we've got a summary table. Again, I mean, CMS like basically winning all the awards. You can see they've got a check mark for all of the things we could find basically, except for this support for at least one code point of this crypto layer linked parallel signature thing that we're saying you should call composite. And I think that's basically it. Yeah, I guess, yes, this part. I don't know if there's two of these, but Mike and I, as we were chatting, we said we should give the group like a strong statement around like how to think about this stuff, or what do we think we should do, or should we just keep talking about this on really, really long email threads, or can we kind of drive it to a point of consensus so it can kind of close off? And I hope Stephen will chime in on that because he's been a big part of those conversations on the list. Do you want our biased position now so you can react to it, or?
Stephen had his hand up. Why don't? Okay,
let him,
but I do want to note we are done in 12 minutes or so. So let's like keep that in mind for Mike Line and stuff. But go for it, and then Stephen will.
Next slide. Are there two? Is there one more after this? Because I did a shorter one.
Oh yeah, or you didn't see these.
Yeah, I want to do this short version. Mike can do the longer one if you want. Sure. But basically, my view is if hybrid should or should not happen, CFRG or other parts of the IRTF or IETF should help answer the why and the with what security properties part of this, so that it's not just continuously debated. We should try and get to consensus on this part if we could. And if hybrids are happening, protocols should be able to share crypto libraries, cryptographic module verification, security proofs. So that's if they're happening, then we should be able to kind of build on a common security foundation and all share review and the benefits of that process, and the registry point that Mike made before. I mean, the open question is, should this registry process be part of what allows us to kind of constrain this and drive consensus around it? This is my biased problem statement for you all to consider. I don't know if you want to go back. You can.
No, I think this is right. So this is very similar to what I said at CFRG yesterday in regards to hybrid chems with RSA. Is like, we know people are going to do this. We know people are going to do this with or without IETF consent. Should we try to make it less bad? Should we try to provide sound constructions, sound combiners? I think 2 years ago we all sort of thought this would be trivial, and we're now learning, greatly thanks to Britta Hale, that it's not as trivial as we thought. And so should we try and help do it correctly, and sort of reduce the amount of roll your own that people are going to do when they try and build themselves migration mechanisms. So the open questions here are, what are the security properties that various IETF protocols need from hybrid schemes? And do those properties get provided by the existing mechanisms, or do we need to define new ones?
So why don't we, those two are enough for you guys?
Yeah.
Okay.
That's it.
Stephen?
Stephen Farrell, I was going to be smart asked and ask, could you put up the slide about combinatorics, but there isn't one. Can you go back to slide 19? So, and I'm not claiming I know the right answer here, but I think if you look at that bullet that says put responsibility on crypto-lib developers, etc., I think that's ignoring the complexity that you're going to end up putting on people deploying things, because we end up with dozens of different code points for all sorts of purposes. And it's very possible that that might just make interoperability worse and make security worse. I don't think that's been properly weighed in these discussions so far.
Does that, off the top of my head here, it's a valid point. Does that change, is that specific to the crypto layer linked, or does that apply to all of them?
I think it applies particularly if you, as you're calling crypto layer, but if you implement these composites beneath the crypto API, I can't see any way to avoid this combinatoric explosion in terms of the number of possible code points, and therefore adding a lot of complexity and confusion and possible non-interoperability, and even implementing key management systems with that many options for how you sign something, I think is a lot of complexity that's not reflected in this slide.
Yeah. So, I mean, the point about the improve interoperability through normal IETF registry process, I agree with everything you said. You know, the only way that I could see constraining those combinatorics pieces is to say, here's the 1 or 2 that you're supposed to do. But even if we were to say that, you can't really stop people from doing whatever they want.
Yeah, I'll stop now, but we can't stop ourselves adding them.
We've got a lot of people in line, and we do need to be out of here in 9 minutes. So, Russ? And there's plenty of other time to talk about this. This isn't the end of it. But Russ?
Russ Housley, we do not have the combinatorial explosion problem the higher up you go, because you're just assigning one code point for each of the signatures that are then being used in the and or the or construct. So I really think that whatever we do at the crypto layer, we do need to make sure it works in all of these protocol environments so that one crypto library will work in all of them.
Thank you. Aaron?
Personally, I'm not really scared about the combinatorial problems. So as long as it's well defined, and in the crypto layer we say, okay, here even are the 5 different signatures that we want to do. That doesn't really, I don't think it is a problem, because they're all transparent to the upper layers. On the other hand, I think that Stephen had another argument, that is the backwards compatibility, that in most cases we still need to implement multiple signatures on the protocol level. And therefore, that's, in my opinion, something that is not really reflected in this slide. That is, let's say, a con of having crypto layer parallel signatures, when you already have to have the complexity of you already have to have the complexity of multiple signatures on the protocol level.
Great, thank you. Michael?
Yeah, Mike Perrock. I'm a little terrified when I see things like, let's let the implementers at the library level handle it, especially when we're saying let's go jam weird things like keys, that then they'll probably try to do weird, strange compression things regardless of how we specify them. So just one of those things that concerns me from like implementation bug nightmare things that will roll out inevitably. I do want to follow on, Ori. I really like your idea of saying, yeah, we should make sure we're getting good guidance from CFRG on some of this, or maybe just decide that, you know, see if they say this something we should even touch or not, right? There's some things here that we might want to just avoid, or come out and say, yeah, we maybe don't want to touch some of this stuff at all for very good reasons. Did you want to respond?
Yeah, I've learned recently we can't dispatch stuff to CFRG, so I think still like worth chatting with the folks that are there that are interested, and I agree with everything you said.
Rowan?
Rowan May. If you, in terms of having this proliferation of, I'm not a fan of having every combination or a large number of combinations. But particularly, I just want to say, if there are any combinations that include RSA, I think we should make sure that we ask that we have a much higher bar in terms of existence proof that it's actually going to be useful, because a lot of the arguments that I've heard the rest of this week about, oh, well, if I have RSA and I'm going to use it in such and such environment, I think when you start to poke on it hard, it starts to fall apart, that it's not actually possible to, that what people want to do, where they say, well, we're just going to add this thing on the outside when they're using RSA, either for chems or for signatures, that it actually falls apart when you analyze it further. Thanks.
The word just is always dangerous in a room like this. So we have a few minutes, but we also, I think we have run through this fairly well. We can certainly have more discussion on this. This isn't like a draft. This is a, what do we want to do? And I think that, so for the working group, that's a perfectly reasonable thing for us to be using for the list. If some drafts come out of this, we can work on it. But so for next steps for the working group, we've got a few things coming up. We will have 1 or 2 interims in the coming months before the next IETF meeting. Not completely clear what those are and when they are. That will be discussed on the list. Not everyone wants to be at all the interims and such like that. Stephen, you have a last bit?
Yeah, just to kind of echo what Aaron was saying earlier, that the OpenPGP working group will be discussing some of this tomorrow.
Oh, right.
And I think I'm one of the co-chairs of that working group. So one of the interesting things will be to try and figure out how to get towards consensus on some of these. It's not clear that we know the answer, but that's something that we'll be thinking about and maybe other working groups will be trying to figure out, how do you reach consensus on these topics without kind of waiting years or without annoying too many people.
So if you get experience on how to get consensus, please send that at least to PQUIP, if not the other places where it's a pain point.
Sure.
Yeah. What? Sure.
Jump in the queue, Mike Allensworth. So yeah, I am the queue. So the one thing that was in the slides that I want to highlight here as a last word is, what do the protocols need as security properties? I think, I would love to see this come from that direction, like PGP to state, here's, if we're going to do hybrids, here's the properties we need, and then figure out which mechanism provides it, is the direction I would like this to go.
Good. Thank you very much. This was, sorry, we assumed that almost no one wanted to come, that all the cryptographers were staying away, and because they're going to real world crypto. We won't make that mistake again, even if there's competing things. It would have been nice if there was more time here. So we won't try to jam stuff into a 1-hour meeting in the future. So thank you very much.
We hit timing.
Yeah, you did.
I feel like we needed to be more. Yeah. And we didn't get our stuff from it.
Thanks.